Okay. So here's an example of a piecewise function. Okay? And this is saying, and you read these from left to right, and this is going to be one of the really hard parts about doing this, is you're not used to doing that. So when you read a graph, it's like reading a book. You're reading stuff in this direction. Okay? So if I'm actually going to read a book and see what happens first, I'm going to go like this. Oh, this is happening first. Okay? So if I'm reading this, this is my guideline to know when this is happening. Okay? I'm going to relate time to my x value right here. And I can see if I take this apart, I'm going to assume this is counting by ones. This is when x is -1. Do you see that? Mm-hmm. So I can tell you when x is -1, this is happening. Okay? Now I'm going to stop reading this one and I'm going to keep reading. Oh. When x is greater than -1, this stuff is happening. When x is less than -1, this stuff is happening. And when x is greater than -1, this stuff is happening. So what I have here is a function that's happening, two different things are happening at the same time. One thing that's happening is this. And remember, that's the same thing as y equals x minus 2. That's just a linear function, okay? Fancy label. And this is also happening. F of x is x plus 3. Or y is x plus 3. So I have two lines going on at once. Okay? One of the lines was this whole line right here. This was a whole line. But it was only happening when x was greater than 1. So I didn't copy this part down. And this was another whole entire line. But just like that income tax chart, it only happened at a certain interval. It only happened when x was less than -1. So can you read the graph?
Yeah.
I mean, you understand what I just told you? Somewhat. Okay.
Why is one of them colored in?
Good. That's a good question. And the reason one's colored in and one's not involves these signs right here. If it has a line under it, an equal sign under it, it'll be colored in. And if it doesn't, it'll be open. Okay? The way to say that two things are happening at once is to put it in a notation like this. A piecewise function. You have one function, but different things are happening at different times. Okay? So, your job, this is not supposed to be done for us. This is our example. This would be the problem in your book. The problem in your book would say, graph this, and identify the domain and range. So how do we even go about graphing this?
Well, you know that you're...
Okay.
You could put it into slope-intercept.
It's in slope-intercept form right now.
Okay.
So how would I go about graphing that?
Well,
It's going to be on the cross -2.
It's going to cross at -2, right? So I'd go up here and I'd make a dot at -2. Oh, -2.
that's...
And then what is my slope?
1.
My slope is 1 over 1, isn't it? So that means I'm going to go up 1 and to the right 1, right?
Okay, how do we know that was our slope?
Because we're in slope-intercept form, and that's our slope.
Your answer is
I know that x minus 2 is the same thing as 1x minus 2. So my slope is 1.
Well, how did we... Oh, okay.
Okay? My slope is 1. So that means I'm going to rise 1 to up and run to the right 1. Rise 1, run to the right 1. Rise 1, run to the right 1. Okay? And I really, at this point, would only have dots on this graph. I wouldn't connect my dots with a line yet. Until I go back and I check, oh, where is this true? This is only true when x is less than -1. Okay? So remember, I'm reading this from left to right. I see my dots. I know where they are. But this is only true when x is less than -1. I know it's an open because it tells me that right there. It's just like the income tax chart. This is only true when this is occurring.
Do you have to go to the...
You have to go on the x-axis to that number. Okay? You have to go on the x-axis to that number. Find your graph on that number, which would be right here. Right? And where are the things that are less than -1? They're this way. So this is my line, so I'd make an open circle and I would say, okay, it goes down like that. That's where it is. Even though the rest of this exists, it's invisible. Okay? Then you go to your other one. Where do I start graphing this?
At the intercept of +3.
Of 3. 1, 2, 3. There it is right there. How do I know what my slope is? It's 1 over 1. I go up 1 over 1, up 1 over 1. I got a little line. Yep, yep, yep. There's the whole line. But wait. It's only happening when x is greater than or equal to -1. So you find your -1 on your x-axis. Greater than is everything to the right of that. So here it is. That's the only piece I want. It's filled in because of that equal sign right there.
Okay, I have a question.
Yep.
This might just be like a weird graph or whatever, but on the first, like the little line part that's on the bottom is like where it starts is down.
Yeah.
-3, and the other one where it starts is up +2. If you look at your two numbers that it gave you, like for your intercepts or whatever, those are like the opposites. Like
Probably for this you'd be all right because there's nothing in front of your x. Okay, I wouldn't. The reason is I'm not even gonna go there. Okay.
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 But
So
is that gonna be that way in all of them, or is this just a weird one?
you check that out for me, okay,
Okay.
Alex? As we go through this, you check that out for me.
So what happened?
Okay? He noticed that this dot, the reason this dot is there, I can tell you right now, is because they put in this equation right here, they put in -1 right here. Did the math and got this. So their first point was going to be at -1, -3. So you can figure out your point that way.
But yeah, but it comes from the other part of the thing.
Yes, it did, but this is a real simple equation.
Oh,
You know,
right.
if it was something else, you weren't going to be able to figure that out.
Okay.
Okay? So yes, you can figure that out. All right? So we graphed them. Now it said we had to find the domain and range. So your domain is the wideness of your graph.
Infinite.
It's infinite to the left, and it's infinite to the right. Are there any gaps in the middle where a graph does not exist?
No.
No, even a graph exists right here, but only right there.
So will they have to like put that both of them are like when it's a greater than or less than signs on the other side of those where it says -1? Will those always have to be the same number?
What do you mean? Like over here?
Yeah,
Will that always be the same number as what?
as the one like above it or below it. Like.
Oh, right here and here?
Yeah.
Absolutely not. No.
Okay.
What about our range? Our range is the tallness of the graph.
All real numbers.
Is it infinitely tall?
Yeah.
Is it infinitely below?
Yeah.
Is there a gap in between where no graph exists?
Yes.
No. Yes.
Yes, there is a gap in here where no graph is existing. Okay? So I do have to limit my range. It's not all real numbers. I do not have a graph between these 2 points, do I? Okay? So what I can do is say my range is higher than this, and my range is lower than this, and that'll satisfy everything else.
Higher
Okay.
than
So I would say this is how you would do it in correct notation. You would go the set of all f of x such that f of x is greater than or equal to, my positive numbers are here. What is this number right here? Because this is the number I'm concerned about.
2.
It's 2.
It's 2, right? So greater than or equal to 2. Or f of x.
Isn't that just greater than?
No, because that dot's filled in.
Oh yeah.
Or
Less
f of x
than
is
or equal
less
to-
than, what is this number? Negative 3. That's how you would say. That's what your range is.
Wouldn't it be and though instead of or?
That's technical. I don't care. Okay? I don't care which one you put.
Okay.
Okay. So